interval, the area, is the interval from -1 to 5. Remember, this is a sum, but this notation is a stretched s, e to 3x dx. This is a continuous function everywhere, especially on this interval, so I can use the fundamental theorem of calculus, which means I have to find the antiderivative and then evaluate it between -1 and 5, plug in 5 and subtract when I plug in -1. Remember we had an example, a general example, so which function prime is this? Is e to 3x over 3. Careful. Please take 1/3 outside, plug in 5, e to the 15th, minus when you plug in -1, e to -3. This is the exact. Now, if you want to check with the calculator, so do not rely on the calculator only, because you may be asked to present an exact number, and no one can come up with this. If you don't know how to determine or how to evaluate a definite integral, you will not be able to come up with this from an approximation, because these are irrational numbers. So don't say, oh, I'm going to use the calculator and I'm going to get a correct answer. You will not. If the answer has to be exact, you will not be able to construct this unless you know how to integrate, please. So use the calculator, definitely, for sure, to make sure you're not losing points, but not as a crutch, please. So, okay, from -1 to 5, and then we have e to 3x, and then dx, and of course I will not be able to know what this is, so I'm going to approximate my answer, which is e to the 15th, and it has to be the same gibberish, identical to -3. Okay, so when I hit enter, I have to get all this. .441. If I don't, I have to go back to the drawing board. So again, if the answer has to be exact, no one can change this gibberish into 1/3 e to the 15th minus e to -3. Please. Don't rely on the calculator. Okay, very good. Do we want to look at anything else, or can we move on to word problems? Okay, we can always come back. Okay, I'd like to start with, let's say, I don't know, these are all kind of weird types of functions. Okay, they're not very friendly. So let's work on a few. Total profit. Let's start with 59. So we're given the marginal profit, which is the 5th root of x, or x to 1/5. Okay, so this is their marginal profit in dollar per foot. Obviously, it's a marginal profit. It's a derivative. It has to have 2 measurement units. Dollars per foot. Okay. From drilling a well, and x is in feet. Okay. Find the total profit when a well 250 feet deep is drilled. So we have the marginal profit, total profit. Of course, is the definite integral from 0 to yes, I thought it was 250, I'm making sure, of x to 1/5 dx. Because we know and we mentioned that many times, when we are given the derivative and we are given an interval, we're basically determining the total, if it's profit, if it's distance, if it's cost, if it's memory, whatever it is. I'm given the rate of change. I calculate the integral of the rate of change to determine the total, whatever that is. This function is continuous on this interval. I can use the fundamental theorem of calculus. All I have to do is find the antiderivative. But that's a piece of cake, because I only have to add 1 to the power. So what do I get? 6/5 divided by 6/5 from 0 to 250. Luckily for me, it's a polynomial. I don't have to plug in 0 because I get 0. I flip 5/6 times 250 raised to 6/5, and I will approximate. And then I will check. So I'll put in the graphing calculator as, let me clear all this, in parentheses 5/6, and then I have 250, and the power is 6/5, and I get approximation 628.56. I have to get the same thing using math and 9, from 0 to 250. And this is x to 1/5. Of course, dx. No integral exists without d something of the variable. And when I hit enter, I have to get the same gibberish. Look at, it's thinking. Wow. It took a while. So it has to be identical. There is a minor error, which is the tolerance of the calculator. So this is way too far. So that is correct. Good. Yes, let's look at 61. Stop me if you have questions, please. Don't let me move on if you have any questions, please. And 61, the marginal cost. So again, we have the derivative, 4x to 1/3. Fine. Find the cost of installing 50. So cost from 0 to 50, installing 50 square feet of the marginal cost, 4x to 1/3 dx. Continuous function here, we can apply fundamental theorem of calculus. 4 goes outside. Which function prime is this? Always increase 1, the numerator, sorry, the power by 1, so 4/3, divided by 4/3 from 0 to 50. I always like the 0 here when it's a polynomial. If it's not a polynomial, then I will not get 0. So I have to flip 4 3/4. Luckily this goes away, times, when I plug in 50, 50 to 4/3, minus when I plug in 0, I get 0. So what I have to multiply is 3 times 50 to 4/3. To find the cost, this is the marginal cost, the derivative of the cost. To find the cost, I integrate the derivative. In other words, I find the area under this function to determine the total value. So after I calculate, then I will check with the calculator, with that feature. Okay, so 3 times, and 50 is taken to power 4/3. Okay, so the total cost for the first 50 square feet, 552.60. Now, checking with math and 9 from 0 to 50. from 4 x to 1/3 dx. No. Dx. Look at that. Okay. Again, there is a minor error of the software. So this is correct. Now let's see what else they want. And I'm sure that you probably don't get the exact same error. You're getting a minor different error. Okay. Find the cost of installing an extra 14. An extra 14 means from 50 to 64. So for the extra 14, cost from 50 to 64 will be the integral from 50 to 64 for x to 1/3 dx. The extra 14. Okay, so what I have to do is just copy the previous entry and replace the upper limit with 64 and replace the lower limit with 50. So the cost for the extra will be 215.40. That's for the extra 14, meaning from 50 to 64. And this is something that we're going to study in the next section. I just want to point out, and then we'll look at more problems. So this is a property of the definite integral. One of many. So here's a function, continuous function, and look at what we had. We had from 0 to 50 and 50 to 64. From 0 to 50. Initially, we determined this first integral, the integral from 0 to 50 from f of x dx. And then we determined this integral from 50 to 64 from f of x dx. But this integral, if we want to determine this whole area, this will be the integral from 0 to 64 from f of x dx. The point I'm making here, what property is this? I can split an integral into as many integrals as I want. So if I want to determine the integral from 0 to 64, I can do it directly. Or I can do this, the integral from 0 to 50 plus the integral from 50 to 64. So if I want to go back just for the sake of the argument and determine the integral from 0 to 64, what do you think I'm going to get?
Would it just be the sum of the two?
Exactly. Absolutely. Absolutely. Thank you so much. That's a property of a definite integral. You can split it in as many pieces as you want. Add them up or do it directly. So I expect 552 plus 215 and some change. Exactly it. Again, because this is a property of a definite integral. You can split it, you can determine this integral from 0 to 64, or this piece plus this piece, or this piece plus this piece plus this piece. It doesn't matter. It's one of the properties of the definite integral. Good. So let's go back to other situations. Okay. Let's look at a company is producing a new product, and the time required to produce each unit decreases as workers gain experience. So it's determined that T is the time in hours required to produce the X unit. Use this information for exercises 67 and 68. Find the total time required for a worker to produce units 1 through 10, and then units 20 through 30. So this is the time required to produce the X unit. Use this information for exercises 67 and 68. So find the total time required for a worker to produce units 1 through 10. I would like to look at this maybe, or physics. A particle is released as part of an experiment. Its speed, so we are given the speed. How far, in other words, what is the distance? And we know that the distance is the antiderivative of the velocity. I'm given a derivative, and I'm asked to find the total distance. So I'm given the velocity, so I'm asked to find the total distance. How far does it travel during the second 5 seconds? So how far does the particle travel during the first 5, and then based on the property that we just discussed, how far does it travel during the second set of 5 seconds? Okay, let's work on 79. So we have v of t, negative 0.5 t squared plus 10t. And they want us to find part A, distance between 0 and 5 from negative 0.5 t squared plus 10t dt. And the second one, the other distance from 5 to 10, negative 0.5 t squared plus 10t dt. Ready for this one? Yes? No? So for part A, what do we get? The integral from 0 to 5, I'm going to copy it here, t squared plus 10t dt. So this is negative 0.5 t to the third over 3 plus 10 t squared over 2 from 0 to 5, which I like because it's polynomial and I only need to plug in 5 because when I plug in 0, the whole thing is 0. So negative 0.5 over 3 times 5 to the third, 125, plus 5 times 5 squared, and I have to calculate that. And the other one for part B, I have the integral from 5 to 10, negative 0.5 t squared plus 10t dt. It's the same function. Nothing changes. Negative 0.5 t to the third over 3 plus 10 t squared, but this time is slightly more difficult because I have from 5 to 10. So I have to plug in 10, and then I have to subtract when I plug in 5. So I plug in 10 first, negative 0.5 over 3 times 1,000. This is 5, so plus 500, but minus when I plug in 5, which is, put it in parentheses so we don't mess up the signs. So negative 0.5 divided by 3 times 125, and plus 5 times 25. So now I have to calculate this, which is basically this, and then subtract it for the second part. So let's see what we get here and what we get here. And then we can check. So negative 0.5 divided by 3. I prefer to put this in parentheses, although it will not make a difference. So negative 0.5 divided by 3 multiplied by 125. And then plus 125. So the first one is 104.167. The second piece is negative 0.5 divided by 3 multiplied by 1,000 and then plus 500 and subtract the previous answer, this one. So I got 229.167. Of course, you can check with Math 9. Any questions on this problem? Any questions?